Hello everyone, welcome to this session where we will see how we can simulate a UR5 robot on Gazebo and control it using Moveit. So this is the overall goal of the series. So first we learn about how do we simulate UR5 robot in Gazebo, and then control it using Moveit. So it's just not about a single robot. We want to have our own custom simulation environment. So probably we'll mount UR5 on a pedestal or a table, or include other accessories like camera, gripper, and put our own things into the environment. So basically we want to have a custom world environment, not that which comes with the universal robot repository. So once we control it using Gazebo, we'll like to build our own nodes or Python nodes to control the robotic arm, and we want to demonstrate some autonomous motion planning using visual feedback, and finally we want to use this entire simulation environment to train some deep reinforcement learning model. So in this video we'll just cover the first part of this series, where we want to just control a UR5 simulation model using Moveit Planner. So these are some web links and tutorials which you should go through to have a better understanding of what I am going to do now. You see the Moveit tutorials. This is the link for universal robot repository, which we will download and use. Then there is a GitHub link where the person demonstrates how he uses UR5 for a pick and place task, and learn about the URDF link, a bit of tutorial about how the Gazebo control works. There's a video that already talks about how UR5 Gazebo can be used with Moveit. I'll see what is the difference between what he has discussed and what we are going to do now. And there is a Moveit RV's quick start tutorial which is also helpful, and will be the codes that is demonstrated in this video have been tested with ROS Melodic on Ubuntu 18.04. So our first step is to install the universal robot package on your system. So essentially it means that you download the repository, the zip repository, into your Catkin workspace and src folder, and then you build it, and if everything is fine, then you should be able to launch the UR5 simulator by running this command. Alright, so there are more information is available at this Git page in case you run into some problem while building this package. Basically it may require installing some additional packages, so which you can do by running rostep command. So we are not going to do the details. You can go through the link and check for yourself. So if everything goes fine, then you should be able to see a robot arm in a Gazebo environment. You can put some directional light to have better visibility, otherwise it looks a little dark. So, and on the terminal it just does show some errors saying that no p gain specified for PID. This is normal. There are some solutions to avoid it, but that doesn't really help. So you can ignore this error, it's not very serious. Now second step is that building our own robot description. See, the one you saw, that it just has a robotic arm. Now the question arises, how do I let's say how I want to put this robot arm on a pedestal or a table. Probably I want to mount a camera, I want to have a table or something in the background, I want to have an environment. So how do I do all this? That means I want to build my own robot description. Okay, so this is where you can decide to mount your UR5 on a pedestal or table, or attach a gripper or camera, so on. So there's a first step, we will just mount the robot arm on a pedestal, and later we'll include other components into our world. So we create a catkin package called my UR5 description inside the src folder. So this is the standard catkin create package process. Alright, and inside this one we create a folder called URDF. Now inside the URDF folder you create this file called my ur5.urdf.zacro file. Inside this provides a description of a pedestal with necessary joint and link information. And just to understand what to include, what not to include, it will be good to go through these files in the universal robot repository that we just downloaded. So this is ur5.launch, ur5_upload.launch, ur5_robot urdf.zacro, ur5 urdf.zacro. These are the files, you should look into it. Okay, so the basic idea is that we will include the ur5 urdf model and Gazebo related files into our own descriptions. So this is how it looks like. So we first define a world link, then we define a link called pedestal. This is the inertia, mass, and everything is specified here. Okay, I just choose high values for inertia. I don't want my pedestal to rotate around x or y axis, so I make this inertia very high, and basically I make it all the high so that it doesn't rotate about any of these axes, because I want it to be more stable. So in a visual I specify the geometry, which is a cylinder. Material is gray, and collision is this collision. Visual and inertial properties are to be specified for each link. So there is this XML URDF link is there on ROS wiki, which you can see for more information. So this is our first file that we make, and we continue it. So we include the Gazebo reference, provide some friction components, and specify the color to be orange. And this is the first joint we define between the world and the pedestal. Then we define some transmission hardware interface. This we have borrowed from the ur5.launch file present in the universal robot repository, and this is the standard common Gazebo description for the UR5 robot, and this is the URDF file for UR5. We just include it here, and then we create another joint between pedestal and the base link of the robot manipulator. Okay, this information is required for loading the functional UR5 model into your environment. So yeah. Now step 3 is that now once we create this URDF file, then we can create a file called my ur5.launch. Okay, and this is similar to the ur5.launch that is available with the universal robot repository. Basically we have now everything here, the world description, robot description, and controller files. Okay, and once it is done, then you can just launch it by using the ROS launch command as shown in the bottom. if you do this, so this is the file here. So this is, we load the empty world. This is the robot description that takes this file which we defined just now, and we use this spawn command to spawn this robot into the Gazebo model. Then we load the controllers. Okay, this is something we can learn from the UR5.launch file present in the universal robot repository. So if you do this, then you will see something like this. As you can see, there is a pedestal now. The robot is sitting on a pedestal. Okay, so this is the command that we give. It still gives an error called no pkn specified for PID on the terminal, but we can safely ignore it. Once you do this, then you can run the ROS topic list, and if you do that, you can see these topics, arm, control command, joint states, all these things, follow joint trajectory. These things will be visible to you, and it is important that you see these things at this stage. Now we saw that our Gazebo model is working fine. So now we'll build a Moveit config package. So you go to this link that shows this video. So there's a video here. It explains how to use Gazebo with the simulated robot UR5, and it explains the whole process. So I'm not going to go through it completely. So I'll just briefly describe what to do here. Okay, basically we'll start these Moveit setup assistant, and we create my UR5 Moveit config inside the src and this folder, and by following the instruction there, we'll either create or modify these files. Alright, and just to know the difference is that we will create a kinematic chain from pedestal to tool 0. This is the only change from the video. So this is how the settings on setup assistant look like. Okay, this is the virtual joints, this is the planning group. Note that I am now creating a chain from pedestal to tool 0. The rest of the things are same. So my file controllers.yaml file looks something like this. So this information we take it from the ROS topic list. Okay, so we know that our controller is ARM controller, namespace is follow joint trajectory, type is this, and the joints are this. This information is available in this UR5 urdf.zacro file, and the joint names are the same, just contains the names of all the joints. Then we modify this my UR5 Moveit controller manager.launch XML. Note that this package is generated by the Moveit assistant setup manager. So we just modify some files and create some others. So this file we modify, we comment this ROS controller line, and we just include our controller that we just created. It is probably possible that we put this description inside this ROS controller and use the ROS controller file itself, but that is something I leave it to you to try it out. Then we create another file called my UR5 planning execution.launch, and this is as per the description available in that video. So basically we include this file joint names, and then this joint state is our publisher. Okay, this we get it from the ROS topic list, and then we launch the Moveit. So here config gives an error, so we comment this line. So once you do this, then you should be able to launch the Moveit in a separate terminal by using this command, it still gives the error. It gives you some error saying that could not find the planner configuration none, so you can ignore it. And there is a Moveit RVH tutorial which you can go through it and learn more about how to use various parts of the Moveit planner. So when you start it, you see something like this. You change the fixed frame here in the global options to pedestal, then you add robot model and add motion planning. So if you do that, you will see something like this. Now using the planning tab here, your current state, your starting state is current, and let's say goal position is home pose, and you can click on plan. If you click on plan, then it will show the motion here in RVS but not in Gazebo. But if you do execute, then it will show the motion in the robot itself. It is also possible to show the query state and the goal state separately. So as a summary, we saw how to add a pedestal to our UR5 robot. This paves the way to include other components to our Gazebo simulation, which will be demonstrated in the next part. Then we use Moveit to control robot motion in Gazebo simulation. So to-do list is there. We want to make use of the Gazebo's model auditor to build models and include them in a simulation, because creating URDF writing on your own is a little bit tricky. So we want to see if we can use the Gazebo's model auditor to build the models and include the STF files directly. Second, you can see that in the RVs we don't see the pedestal. So maybe we can include a mesh file that will help us see the pedestal as well. Okay, so this is it. So we'll just show how my package looks like. So I'll turn everything so I'm turning off all the previous instance of the program. So my workspace is Catkin WS2, and if you go to SRC folder, you can see that I have this my UR5 sim, and inside my UR5 sim you have this my UR5 description, where we have our UR5 Zacro file and this Moveit config, which is created using the Moveit assistant manager. So cd my UR5 description, if you go there, you can see that you have two folders, config and launch, and URDF, 3 folders are there. So if you go to URDF, you have this my UR5 URDF.zacro. Okay, so and then if you go to config, then we have this is not required, PID gains.yaml is not required, so you don't worry about this part is not required. In fact, I'll remove it from this. So we have just launch and URDF, so cd launch, so you have this my UR5.launch. so this we already described. So this is my UR5 description. Now let us see the my UR5 Moveit config. So it has two folders, configured, launch. So here we create this file controllers.yaml and joined names.yaml. Others are generated by the Moveit package, which we leave untouched. And now we go to the launch file. In the launch folder, we modify this file control manager.launch, and this is the file we create. This is what we will call to launch this one. So rest of the things are generated by the Moveit package. So if we go back now, if I launch the Gazebo model, so we do ROS launch, my UR5 description, my UR5 dot launch. You can see the pedestal and the robot. So we will just include some light here, okay, so that the visibility is a little better. Okay, so as you can see, we have this robot on a pedestal. As you can see, there is an error here, no gain specified for PID, which we can ignore. Now in another terminal we will start the Moveit planner. So we go ROS launch, my UR5 Moveit config, my UR5 planning execution dot launch. So here as well it gives some error related to could not find the planner configuration none. This can be easily fixed, it's not a big problem, but we don't worry about it. So in the RWitch it looks like this. So as I mentioned here, I will change it to pedestal, so the error goes away. Now I add the robot model. So as you can see, robot is here, and the pedestal doesn't show here because I think we don't have the mesh for it. So I'll have to create the mesh. If I do that, probably it will be visible. And then I add a motion planning here. So if I do this and okay, so what we do here, we say the start date is current state, and goal state we say home pose. So the orange, it shows the goal pose, and this is our current state, which is the same as this one. So we'll put it here. Yeah. So now if we do a plan here, you can see the planning is happening. Okay. And now if I execute, you see the robot is moving both in the simulation as well as in the RWitch. So now if I do it goal pose as the all zeros, now we change the goal position, which is shown in orange. So I can do a plan, and if I execute it, the robot goes back to this one. So again we can do this, we current position, and we go to the home position again, and then if we do plan, it happens here but not here. But if you do execute, then go to this one. So that's how the system works. So we will add more components to it. Alright, so we'll stop here, and thank you for your attention.